We interact with artificial intelligence so seamlessly, it's easy to forget what we're actually talking to. From the filters in our inboxes to the assistants in our pockets, the sheer fluency of the technology actually tricks us into assuming a thinking mind exists behind the screen. That illusion is remarkably fragile. You can take a supercomputer capable of defeating world-class chess players, but if you ask that same machine to explain why your houseplant is dying, it has nothing to say. This gap exists because of the difference between artificial general intelligence, a theoretical, flexible intellect that can learn any task, and narrow AI. While the former remains the territory of science fiction, narrow AI is the strictly bounded technology running our world today. You'll often hear this called weak AI. The name is misleading. A system that can rapidly scan millions of medical images for early signs of disease isn't feeble or slow. It is weak only in the sense that its intelligence cannot stretch beyond its specific programming. It stays in its assigned lane. We project human traits onto these specialized calculators because their results look like something a person would produce. In reality, there is no bridge between the math that plays a board game and the common sense we use to navigate the physical world. To understand how these boundaries are built, we can look at a practical example: designing a support ticket bot for an online furniture company. The first step is task definition. Developers must set absolute limits on what the AI is allowed to consider. For this bot, its entire world is reduced to sorting incoming messages into exactly 6 categories, from shipping updates to assembly help. We also create negative constraints. We explicitly forbid the AI from issuing refunds or making final account changes. We draw a hard line between the automated sorting process and the human authority required to spend the company's money. Next comes data collection. The system needs examples to learn from, so it is fed thousands of historical support tickets that have already been resolved by people. The algorithm looks for patterns in the text. It doesn't understand what a table is, but it learns that the word shattered has a high mathematical correlation with the category for damage delivery. This is the same logic used by high-end generative AI. Whether it's drafting an email or creating an image, the system is evaluating bounded patterns in data to predict a specific output. Because the machine is blind to the meaning behind the words, it operates with incredible efficiency. It processes the statistical shape of information, but it is incapable of actual empathy. Problems emerge during validation when the system hits an out-of-distribution error. This is the technical way of saying the AI has encountered a scenario it never saw during its training. Consider this message. The wardrobe arrived this morning and one of the mirrored doors is shattered. I cut my hand while opening the box. The AI identifies the word shattered and immediately routes the ticket as a routine damage delivery. It completely ignores the report of a physical injury because it lacks the common sense to recognize that a cut hand is more important than a broken mirror. To prevent these failures, developers write escalation rules. If the system detects keywords like injury or doctor, it is forced to stop and hand the ticket directly to a human supervisor. Safety in narrow AI depends on the system's ability to recognize its own limits. A well-designed model identifies the edges of its training and flags those moments for human review. If we leave these systems to run in a closed loop, we risk scaling human error. Because AI is trained on data we provide, it can silently replicate historical biases and inequalities hidden within those records. This gap represents automation bias. As humans, we have a tendency to trust a polished interface and a confident output simply because it came from a computer, even when that output falls outside the machine's actual capability. Treating AI as a blanket solution is like buying a hammer and wandering through an office looking for things to hit. It ignores the specific requirements of the task at hand. Governance requires more than just good code. It needs a named human owner for every major decision, a way to track when the model starts to lose accuracy, and a clear path for people to contest the machine's results. Technical progress is not the same thing as trustworthiness. A faster system can simply make the wrong decision at greater speed. Success with narrow AI starts with a perfectly defined task and an understanding of where the algorithm ends. The machine provides the calculation, but the context remains a human responsibility.